Hi, so in this video we are going to discuss exception handling in Python. So basically exception handling is an event or some situation uh, which Python is not able to handle. When you run a code and something happens to your code and Python doesn't know what to do with that situation, then it raises an exception. So we are going to discuss um, the kind of exception we may come across while running our code and how to fix those exceptions or how to handle those exceptions. This is what we are going to discuss in today's lecture. So, for example, uh, let's discuss a few things here to have an idea what exceptions are in Python. So there are two kinds of error you can have in your code in Python. One is syntax error, when you write something in a way that is not allowed in Python to write, that is syntax error. So it's very easy to spot syntax error. Usually when you make an application or you make a software, you don't have those syntactual error. Most likely you won't be having any kind of syntax error because you would have already fixed those syntax error, but you may encounter some exceptions. Usually we get these exceptions in programs or applications where some user input is required. So for example, if software requires input of an integer but user enters a string, then Python won't know how to handle that. So we have to make sure that our code is able to handle such situations. So one of the most basic exception is division by zero. So let's say if some part of your code is suspected to give you division by zero, then Python won't be able to handle that, and it's going to raise an exception. And there are some built-in exceptions in Python which have their names. So we are going to discuss and we are going to go through the list of some common exceptions. So for example, I divide 2 by 0, so I get this answer. So if you look at this, it says that um, zero division error. So this is the name of the exception. The exceptions are actually objects in Python. So, and this is its description that this exception is going to show up when a number is divided by zero. And there are more exceptions. There are many more exceptions like this in Python. So for example, if I try to calculate square of -1, this is something that Python doesn't know how to handle. So for that, let's import math module because square is in math module. So sq math dot sqrt of minus, let's say 1. So you see that we get another exception. The name of that exception is value error, and this line is the description of this exception. Okay, for example, if we write a code here, I just want to print this, print 2 divided by 0 here. I save it, I run it, and I get a trace back. So this is going to tell me that exception is zero division error, but this is also going to tell me the line number that the error has happened at line number 4. So when we build an application or some software and we give it to the user, so when an exception occurs, we don't want user to see all these lines because user might not be able to understand what these lines means. So we want to handle these kind of situation in a way that are user friendly. And then this is one reason, and another reason is if you, let's say, if you make some sensitive software and that requires some kind of input from the user, and let's say user enters the wrong data and this kind of message gets printed on your software and somebody wants to hack your software, the hacker is going to get some clue from these lines and how your code is written, where your code is saved. So we don't want to show these kind of lines. So this is all about exception handling. So we want to handle these kind of exception in a more professional way. To handle these kind of exception, we use try except clause. So the tries block is going to have something that we want to try, and except block is going to have description of the exception, what kind of exception has occurred. So let me just do it here. Let's write a simple code where we have two numbers, a takes some value and b takes some value. So in a more realistic code, we will be asking these values from the user, and then there's an expression here that has to be calculated. So let's say the expression is a divided by b. So depending on the values taken from the user, this expression might raise some exception. If b is 0, then this is going to raise some exception, and this is what we are going to get. So whatever statement of your block is expected or suspected to give some kind of exception, that we put in a try block. So try, and we are going to try this here. So under try we put an expression which is suspected to give some kind of exception, and try block is used with this except. So here we are going to write the type of exception. So we know that from this expression we are going to get this kind of exception. So I will just write this exception here. So this code says that try this expression, but if this expression raises exception like this, then you can write something here. You may print some kind of message here, or you may want to write some kind of line that you want to be executed. So I'll just print here the only message that division by or can't divide by 0. Now if I run this code, I'm not going to get these all lines. I will just get this line. So when this code tries this expression, if this expression gives this kind of error, then this line is going to be printed. So let's save it and run it. So when you run it, you see that you don't get anything. You don't get these lines, you don't get this line number, you don't get a message which tells you the kind of exception you are getting. It simply prints this line, can't divide by 0. Now if your software does like this, then it would be easier for user to understand what is going on. User may not be able to understand these lines. That's why we have to manage these exceptions. So if Python is not able to evaluate this expression, if this expression gives exception of this type, then this message is going to be printed, or whatever lines we have under the except block, they are going to be executed. We can also use else with try except clause. So you can use else here. So if Python is able to calculate this expression and no exception occurs, then this else block is going to be executed. So if we are able to calculate this expression a divided by b, we can simply print a message that answer of division is, and you may print this value here. Let's save it and run it. So it says that we can't divide by 0 because the value of b is still 0, but you see that this else block has not been executed, because this will only be executed if there is no exception here. If this try block does not give any exception, in that case else is going to be executed. In other words, if you're able to evaluate this expression, then else is going to be executed. If you are not able to evaluate this expression, then and there's an exception of this type, then the except block is going to be executed. Now let's change this value here 1. Now you see that there will be no exception here. We will be able to calculate this division. So the except block is going to be skipped now, and only else block is going to be executed. Now let's run it and save it and run it. So you see that we get this answer of the division is 2. So another use of exception handling is, even if you get some, let's say we have 0 here, even if we get some error here, this try except block is going to handle this exception, and they're going to print this message, and rest of the program is going to work without any problem. Meaning that if you are able to handle this exception properly, our code is not going to break all of a sudden. So even if b is 0, you have some more lines here. Let's say you have some more lines here, so you may print a message here that the code is still running. So if you see this line has nothing to do with this exception. So these three lines actually complete the exception handling. So this is a part of the program which is not related to this exception. So even if b is 0, the program is not going to end abruptly. It is going to still continue and execute rest of the statements. So if you run this, so you see that you get this message here that you can't divide by 0, but the next line which is not related to this block is still running. So if exception occurs at some part of the code, we don't want our entire code to suffer because of that. We still want other part of the code to work without any problem. So now let's comment this and let's construct a class, and name of the class is calculator. So we are making a simple class that is going to work like a calculator. So we are going to have three or four functions, plus, minus, division, and product. And even if the user enters two number where denominator is 0, we want that calculator to still work. That particular part of the code may not work. For example, the division function is not going to work, but rest of the code is still going to work. This is I'm going to demonstrate here in this class, because if you have a calculator, even if you divide some number by 0, it tells you that you can't divide by 0. The entire calculator does not break, it still works. So let's define something like that. So I'm going to define a class by the name of calculator. So this class is going to have only two attributes, that are two numbers that we are going to pass to that are going to be attributes of the objects made from this class. So self, let's pass these two numbers a comma b. So self dot a is equal to a, self dot b is equal to b. So let's construct some methods. So first method is going to be a function that is going to add two numbers. So I would call that function plus. So it's going to take only one input, which is the object, and the object is going to have these two attributes. This function is going to return the sum of these two numbers, self dot a plus self dot b. So this is my first function. Now let's define another function, def. This is going to be a product function. So again, it's going to take only one argument, and it's going to return a product of these two numbers, self dot a into self dot b. Now let's define a function which is going to divide these two numbers, def divide self. So it's going to return. Now we can put here this try except block, because there is a possibility that we get division by 0. So I will say try self dot a divided by self dot b. So try this self dot a or self dot b. If some exception occurs, and we know that what kind of exception is possible here. So this is the exception we are expecting here. So let's copy this here, and this occurs, that we are going to simply print that can't divide by 0. And if Python is able to successfully evaluate this expression, then we can have else statement here, else, and else, in else we can return this quotient, self dot a divided by self dot b. So let's keep these three functions, plus, product, and divide. Now let's save it and run it, and let's see what happens. So we have run this code. Now let's construct an object. So if object name is x, then x is equal to calculator. So we have to pass two numbers here. Let's pass 2, 3. So we have created an instance of this class. Now x dot, if you want to calculate their sum, you simply have to use this function plus. So x dot plus is going to be sum of the two number, which is 5. Similarly, you can try x dot product. So you'll get the product of the two numbers. Now if you divide x, use x dot divide, you will get the division of the two numbers. So the real calculator that you have is also has these kind of functions, and every button corresponds to a function in your calculator. Okay, now let's try to construct another object where the second number is 0, and let's see how our code works. So now if you use this divide function for this object, you will see that it says can't divide by 0, but it does not break the entire program. This class is still useful even though it is not able to give you any answer for this object, but the other functions of class are still useful. For example, you can still calculate product. So the product is 0 because one number is 0. So this is the advantage of handling exception like this. So the part of the code which is expected to give some exception has been handled very nicely here, so that it does not have any effect on other part of the code. As I said, there are many exceptions, and you can experiment here to find out many exceptions in Python. For example, if I try to open a file which does not exist, then Python is going to raise an exception. Let's see what is the name of that exception. So for example, if I try to open a file dot txt, and let's use R here. So I don't have this file. This file does not exist. So if your code tries to open a file which does not exist, it is going to raise an exception. So let's see what is the name of the exception. So this is the name of the exception, file not found error. Similarly, if you try to access, let's say this is your list. A list has these items A, comma B. The list has two items, so I can access only this item which has 0th index, and this item has first index. So I can try to, if I want to access 0th, I can get it. But let's say if I try to access 2, so this X does not have any item at position 2 because it has only 0 position and first position. So it's going to raise an exception, and that exception name is indexed error. So you can practice and try to make a number of errors here, and you will see the corresponding information. So it tells you the name, and it also tells you the description of that exception. So I have 3 files in my folder. So I have 3 text files containing marks of students in 3 subjects. Let me show you. So here I have these 3 files: accounting text file which has marks of 20 students, econ text file which has marks of 20 students. Similarly, math has marks of 20 students. So I'm going to construct a function, and that function is going to take file name as an argument, and then function is going to calculate average, read that file and calculate average of the marks given in the file. So let's first construct a function. Def function name is let's call it score average. So this function is going to take only one input, and that input is file name. So first thing that we have to do inside this function is to try to open a file. So here we have to use exception handling, because this is quite possible that the file we are trying to open is not there, or the file is corrupted. So this is going to raise an exception here, and the exception is going to be this exception that we have just checked here, file not found error. So let's use here the try clause. So we are going to open a file. File is equal, f is equal to open, and file name is the file name which has been passed to this function. So file name, and we simply want to read this file. So So if this function does not, if this expression does not execute successfully, then this is going to raise an exception, and the exception is going to be of this type, that file not found error. We suspect that this line might give an exception. That's why we have to write here except file not found error. And if we are able to successfully open this file, then what we want to do is has to go in else block. If we are able to open this file, then we want to read the data from this file, and we are going to store that data in a variable student score, and we can use this read function to store entire data at once and this student score. But remember, when you use this read function, the entire data is retrieved in the form of one string. Since we have to use score in order to calculate the average, so we are going to convert this one string or the entire data that is in the form of string into list, and then we are going to use entries of that list to calculate the average. So once we have read the data, we have to close the file. Let's first close the file. Close. Now we will convert this string into list, and for that we use split method. So student underscore score. So we are going to use split method on this string. So we are storing this string in the same variable student score. So previously the student underscore score is in the form of a string. Now student underscore score has a list of marks. So now let's use for loop to calculate the average of the marks. So for I in range. So range is going to take argument length of this variable student underscore score. It's going to tell us the number of students, student underscore score. Now we have to define a variable sum here, so I can assign this sum variable 0 value here. So sum is equal to sum plus, so every entry of this list is a string. When we read data from a file, that data comes in the form of a string. So every entry of this list is a string. So we have to make sure that we convert that string into integer. For that we can use int here. Int student underscore score at ith position. So once for loop is done, we will have this total sum. So we are going to return from this function the average of the score. So we are going to return sum divided by length of the student score. So we have constructed this function here. So this is showing some error here. Okay, so we have to have something here in this block. If you don't want to write anything, you have to write pass here, but we do want to write here something, that we want to print here the message that file with this file name is not found. Okay, so our function is ready to calculate the average of a file that we are going to pass here as an input or as an argument to this function. Now let's use this function to calculate average of multiple files using for loop. So to use that function, let's first construct a list of files. So name of that list is file names, and this is going to have a name of the file that I have in my folder here, and these files are math.txt and econ.txt and counting.txt. So I have 3 files here. So I can use for loop to calculate average of these 3 files using this function. So for file name, so file name is going to be iterator of the for loop. You can give any name here, but it's more descriptive. So file name in file names. So we are iterating this variable in this list, and this list name is file names. So what we are going to do here, so we are going to print here the average. So we can say that the average marks in file name this could be any file. First time it's going to be math.txt, second time it's going to be econ.txt, and third time it's going to be accounting.txt. File name is, so what is the value? Value is, so the average marks is going to be the value returned by this function at this file name. So I'm just going to print here the output of this function, score underscore average at file name. So for every file, we are going to print this statement that average marks in the corresponding file is score average, the function value at that file, and the function value at that file is going to be this value returned by the function. Now let's save it and run it and see what happens. So if our code runs successfully, we are going to get average of these three files. So let's run it and see what happens. So when you run here, so you get the average marks in math.txt is this, and similarly you get average marks in the other two files. So this time no exception has occurred in our code because all the files are available. There is no missing file. But now if I put any random file here, let's say I write here physics.txt, and that file I don't have in my folder. Now it should raise an exception that this file is not found, but it should still calculate the average of rest of the files. Even if you put this file at the first position, let's say put it here, physics.txt, program is still going to calculate averages for rest of the files. So this is the advantage of exception handling. Even if one part of the program breaks, rest of the part is going to work. So let's save it and run it. Okay, so the first file, it says that file physics.txt is not found, but still the function is able to calculate averages of the rest of the file. So the average marks in physics.txt is none because the function does not return anything here for the physics file. So the example we have discussed so far here, in this example, so try block raises only one exception. There is a possibility that you could have multiple exceptions in your try block. So let's do one example of that. So we are going to write a function that is going to solve a quadratic equation. So you will see that in this code we are going to have a statement in try block which possibly can give more than one exceptions. So we are going to solve this equation. So ax squared plus bx plus c is general form of quadratic equation. So now let's write a function. So I would call it quad solution. So this function is going to take these three arguments, which are the coefficient of quadratic equation. So in this function we will need to use square root function. So we need to import that function from math module. So from math import sqrt. So we are going to have this try block here. So in try block here we are going to have two expressions. One expression is going to be discrement of this quadratic equation, which is sqrt b square minus 4ac. So if this b square minus 4ac is negative, then this expression is going to raise an exception, and second exception that we can have is from this expression b divided by a. So if user enters 0 here, then this expression is going to give an exception. So now we are going to have two exceptions here. So first exception is going to be negative square root of negative number. So let's see what is the name of that exception. For that we have to just call here import from math import sqrt. We just want to check name of that exception. So sqrt of -1. So name of that exception is value error. So we are going to have value error exception here in case Python encounters minus in sqrt. if this is the case, then roots are going to be imaginary. So we are going to print here that roots are imaginary, and we can write or calculate those roots here. So let's say im is the imaginary part of the root. The sqrt of b square minus 4ac. So since this is going to be negative here, so in order to calculate this expression and write this expression in the form of complex number, we can simply multiply this by -1 so that we are able to calculate this expression, and the real part is going to be b over a. So let's print here the two roots. So print, so imaginary part plus I comma real part, and let's give it some space before we print the next root. So imaginary part comma minus iota comma real part. So if this exception occurs, so this is going to be our answer. So we have another exception here in case when user enters 0 here. So in that case, the exception is the same exception that we have used before, 0 division error. So let's copy it and paste over there. So this is our exception. In that case, we simply print that can't divide by 0, or you may say that this is not a quadratic equation. With a equal to 0 here, you get this term 0, so this is not a quadratic equation. Or you may simply write here can't divide by 0. So now you see that in try we have two statements, and every statement can give a different exception. That's why we have two except statement, and we can also have a else statement here. So if neither of the two exceptions occur, then this else is going to be executed. In that case, you are going to have a real root. So let's print here that the roots are real, and let's print the value of the root. So we have to calculate imaginary part, or this part, the discrement. So that is sqrt of b square minus 4a and c, and the real part is going to be b over a. So let's print these values. Print imaginary part comma or plus real part. There is no iota here because this is just a real number, and imaginary part here, imaginary means the discrement part of the root, minus real. So this is going to be root in case no exception occurs. So our function is complete. Let's save it and run it. So quad sol. So let's give some inputs here, some random values of these coefficients. So 1 comma 1. In that case, we are going to have imaginary roots because this exception occurs. You get this value negative, therefore this exception occurs. So this block gets executed. Similarly, if you have 0 here, let's say the first entry is 0. In that case, this exception is going to be executed. So we are not calculating anything here, because when a is 0, this is no more quadratic equation. So when you have this, you get this answer, can't divide by 0. Similarly, if you have let's say 1, 5 and 6, in this case you are going to get real roots. So no exception occurs, so you come here and this block gets executed, so you get this answer. Okay, so there are some more options for exception handling. For example, there's a try finally block that you have try. You have some expression here, you try it, and then you have finally, and you have some expression here. So this is used when you eventually want to execute some statement here. So whether you get an exception here or you don't get an exception here, you simply want to execute this part. For example, if you try to open a file here, so let's say math.txt for reading purpose. So if you are able to open this file, or if this file does not exist, meaning that if exception occurs or not, you want to simply close this file. So if the file object is f, then f dot close. So you always want to close a file whether you are able to open the file or the file was a corrupt file. So we always want to close that file. In that case we use this combination. So this statement is always going to run whether you get an exception here or not. So this is the purpose of try finally block. There are many other options in exception handling. For example, you can construct your own exceptions using classes. That classes are going to inherit exceptions from the Python built-in exception class. So I'm not going to discuss those options here, and we don't need them for now. So before I end, let me just show you some common exceptions that we usually come across in Python. So these are given in this file. I will upload this file on LMS so that you can see and use them. So you see that the arithmetic error is just one exception, and this is description. Zero division error, we have just used it. So name of the exception and its description. So we have many of them. So these are just few common of the exceptions that we usually get in Python. As I said, there are many more advanced options in exception handling in Python, but for this course, what we have discussed so far is more than enough. Thank you.